which is our keynote talk. And I'm very happy and thrilled that she was able to make the trip today. And I'm happy to introduce Dr. Robin Murphy from Texas A&M University, where she is an emerita professor in computer science and engineering, also a courtesy faculty member at Carnegie Mellon. So Robin, please take the stage.
Well, good morning, and as we say at Texas A&M, howdy. It's wonderful to be here and to see in person and work with you. And I've just so enjoyed Dr. Rahman's talk. It just so resonates. I've been working in disasters for over 30 years. I've been in I tell people I've been in 30 disasters, not of my own making. So I just really, before I talk about robots and humans and how the rescue and beyond rescue and those types of things, I just want to make it clear that I am representing a large number of very talented people who have done a lot of work, and they've done the majority of the work. And so it's just great to be here and represent them. And I'll try to call them out as we go, but there's just so many great partnerships that we have. All right, we can see how this works. Nope. I hit the wrong thing. Let's see, that name Murphy. Let's see if we can get this back. Okay, lots of books, lots of things, traditional academic and the humanitarian awards. Let's look forward now. What I want to talk about here is what are disaster robots? And they're not just drones, the different types. What are disasters? We heard a little bit about that, and what makes them so hard for AI and robotics? Where are those challenges? Where do robots and AI come in during disasters? I'm going to be using hurricanes, Harvey and Ian in particular. You know, y'all are interested in wildfires. You don't have hurricanes here, but it's the same process overall, and see some of the opportunities and some of the problems. And I think thinking about what's the future, where can you go with these things, both for the Navajo Nation and in general, and just end with some takeaways. So what are disaster robotics? Probably, I think a lot of people, when you think of disaster robots, you think of something like this, you know, some sort of humanoid that's going to replace a responder. And nope, that's not actually it. Let's look at the real. So they were first used, ground robots were first used in 9/11. Very small space. This was the volcanic eruption in Kilauea. Those little blinking dots, those are trees spontaneously combusting into fire due to the heat of the lava. So that's some highlights of where we've been. But you notice the robots didn't really look like that humanoid, and they weren't doing things like carrying people out of fires. And so we've been there at 33 disasters. Our Center for Robot Assisted Search and Rescue with us in Florida State University, which has the drone program that's used by the state of Florida for emergencies, and they do a lot of training. And it really started in 1995, and then got with the Kobe earthquake and the Oklahoma City bombing, where both us and the Japanese in Kobe realized that these small robots that we were talking about, how small could you make robots to put on Mars and still be functional? Take that same extreme environment and consider what about these types of disasters. And then by 2002, it actually got acknowledged by the roboticists as, yes, this is a really separate, hard problem. And in some ways, it's harder than planetary rovers because you don't know as much about Mars as you do, or you don't know as much about disasters as you do about Mars. All right, so what makes them hard? So I said, kind of harder than going to Mars. Well, one thing is that disasters are different than routine emergencies. A routine emergency might be, the firefighter's going to a building on fire. That's kind of normal. An emergency medical, an ambulance, that's kind of normal. It's an emergency, it's time, but it's there. So we say that a disaster exceeds local resources where you're going to call for help from the county, the next chapter house, the state, somebody you need more experience. It's more than you can handle, which is common. So there's all these methods already set up for that. And it could be very wide area, like a big wildfire that's covering a lot of area, very small, like a building collapse, like in Miami, that was one just block in Miami Beach. So it could be either one. But it's really hard cognitively. All of a sudden, everything's going wrong. Because it's not routine, you kind of have to, you're kind of getting stressed out trying to remember all the things you're supposed to do. So it's there, and you don't get a lot of sleep for the first 52 hours. From us as computer scientists, this is also a problem because they're different every time. Every disaster, even though it's a hurricane, it's kind of different every time. And so that makes it hard, that repeatability for research, because we like to be able to hold everything and then repeat and check that. And what's worse from a robotics and software process, what's both worse and good is it's dual use. Robots and software, since they're so rarely used, what you're doing is you're taking stuff used for the military or for surveyors or from the commercial videography markets and just pulling it over. Because if you tried to pay for something or build something specifically for search and rescue, you'd never be able to afford it. And nobody, does your fire department have extra money? Probably not. No one does. So you have to look at this dual use, but it also means you have no leverage, right? In terms of low volume, you can't ask for people to build stuff for you. Okay, and the other thing that's both exciting, and I'm going to hit this over and over again, and kind of scary, is that it's formative. Even though we've been using robots for 30 years and drones since 2005, it's still in that age. The first 20 years, you're just trying to figure out if any new technology, even now with the internet, figuring out how you're really going to use it. So we say it's formative, not normative. So we don't know how to make scenarios. We don't know how to tell you how to do it. What we can do is say how it was used the last few times in there. So that means there's lots of opportunities to figure out what to do and how to best use it, as you saw from Dr. Rahman's talk. All right, well, where do robots and AI come in during a disaster? Well, think of this is a logarithmic scale, so more time, like 120 hours, 6 hours, 12 hours, 18 hours, 24. 24 hours, one operational shift is a big deal. So the disaster happens, and within 6 hours, usually you're going to see responders in the field. And if it's state of Florida or one of the states with drones, they're going to have, and as a hurricane, they've got the drones deployed, starting to take data, getting this imagery. The imagery is going to be used primarily for what we call rapid needs assessment. There are like 9 missions you can do, but the big one is the rapid needs assessment. And that's going to say this neighborhood is wiped out and we've got to get resources there as fast as possible. This neighborhood has 1 or 2 houses, they're fine. Those people have neighbors, they can just go to there. So you're trying to, or this bridge is taken out, responders can't come from this way, they're going to have to come this way to get into the affected area. So they're trying to make those rapid tactical decisions. And they would like, worst case, to get it within the first day for the 6 a.m. deployment cycle for the next day. So typically the responders are going to get all their data, and if they can't make it during the disaster and at night, about 6 p.m., 7 p.m., they go into a planning cycle, finish that planning cycle up about 2 a.m. in the morning, and send out everything for everybody to do at the 6 a.m. start and brief out. So if you can get things either by the end of the day, that first day, it makes a huge difference. If you can't get to the next day, well, then you lose yet another 24 hours. So you want to, so it's a time thing, as much as you can do. And of course, that real time, being able to look at data immediately back at one of your things and say, oh my gosh, that neighborhood's wiped out, versus it's important. So we're going to try to do that. So let's see what we did at Hurricane Harvey. Okay, let's see. Come on, you can play, you can do it. This is not my computer, so my apologies.
The Center for Robot Assisted Search and Rescue at Texas A&M's Engineering Experiment Station has been working with Fort Bend County Office of Emergency Management to provide small unmanned systems, aerial vehicles, and even marine vehicles to be looking at the underneath bridges and the river. What we've been doing is providing small unmanned aerial systems primarily to give aerial imagery so that the officials can see what they're doing to make real-time decisions.
We believe this is the largest formal deployment by public officials of small unmanned aircraft systems for disaster response in our nation's history. These drone platforms working from different elevations have provided our local emergency management team with aerial photography at multiple scales and in high resolution. We have the ability to adjust unmanned aircraft flights in real time to assist with search and rescue operations or changing flood conditions. The teams were comprised of federal, state, and private organizations and agencies from across the United States, all working together to help the citizens of Fort Bend County, Texas.
And so it gives you a little bit of an overview of there. And as you start looking at Hurricane Ian, which was the third costliest, Harvey was the second, depending on who you count, first or second. You start looking at, in this case, we had a lot of deaths associated with that one. The damage is there and doing the damage assessment. And as you start looking at that, what happens there is that you start seeing problems and opportunities. So it's great. It's being used. You can tell that the emergency managers love it. Even in Harvey with 2017, winning awards for reopening a bridge 2 weeks earlier, the impact. Being able, they don't count saving lives, but they know that they did because they could get to stuff. But now we're beginning to see after Ian, with this huge deployment, one problem and one opportunity and one bonus opportunity that I want to talk about. So I'll be talking about the frequency of human error in processing the imagery, and then I'll talk about shortening the time for interpreting it as some of the opportunities there. So what are some problems and opportunities? And remember, the big point here, we're not focusing in this case on working at making those low-cost drones better. We're letting the commercial market do it because we can't really duplicate that process. So we're really gonna focus on that data to decision, how to best use it. Well, the first problem is that the data to decision process, not just flying the drones, but how do you get that data back and into the right hands, has got too many errors. For instance, at Ian, we had 34 missions. We found 51 instances of error, of human error. One crash, so that wasn't too bad. Most of these errors weren't fatal, but they slowed things down by hours, and in some cases caused an entire shift to be missed. All right, so only 3 of the 34 missions had no human errors. Well, why is that? Well, these drones are often flown autonomously. Is it bad autonomous software? No, it was split between, hey, we want you to go look at this and get us a couple of really good pictures. or a short video like a trailer for a movie, or we want you to do a very thorough mapping. Didn't matter each one, we still saw errors about the same. So why would that be? Why would the pilots be making errors? Well, it turned out we had noticed this years ago, and started with Katrina, and then not Katrina, with Harvey and the Kilauea, that volcanic eruption. We were starting to see what we thought was fatigue. And what we found out with our colleagues in cognitive science, after 1 day of flying, the fatigue is equivalent to blood alcohol of 0.05%. Well, 0.04% is the max for aviation if you were flying a plane. Now, we had seen this and we had said, hey, there's some problems with fatigue, and everybody's saying, well, no, these are toys. What can drones, what could happen if they crash? Well, very little, but look at that loss of data, slowing the process down. And so we went back and we were able to duplicate with Florida State, and all of the operators that flew at Ian came back, and we duplicated all of that with an overnight exercise, which we called What We Do in the Shadows after the TV show. And we found out that indeed it was there. So if you look at the errors that were coming from following directions, when you have multiple groups come together and you say you've got to follow these particular directions, they started off not doing well, following directions well that were different from their agency, and they were consistent. But the big one is these are the times of the night. This was about 4 p.m., this was about midnight, this was 2 a.m., this was 8 a.m. They said they weren't fatigued, but look at the errors dropping up after midnight, going up after midnight. And what was fun, this set of flights, we gave them the same flights and tasking as at 4 p.m. the previous day. And by 8 a.m. the next day, they were too tired. They didn't even notice. No one realized they'd been sent back to the same place to do the same mission. And they were arguing with us. They said, that can't be right, but it's true. So that's how tired you get and why we need AI to make things simpler for these types of things. Now let's look at another opportunity that comes up. Well, another thing that we consistently see, and once we're getting all those drones doing all that, we're working with a group who's doing recovery work in Jamaica, and they're saying, wow, we've got too much data. It's like, yes, we know that, right? So look at that. So you've got, when you're trying to get these type of data, you're getting 300 gigabytes of images a day over a 2-week period. No one can look at it. You can't even upload it. You're taking passport drives and driving them over to some place to do it. So the problem here is that you've got this imagery and you can't process it fast enough to get into the hands of people to do the deployment, to do the tactical deployment. And there's another aspect. So at the same time you're missing, here's the opportunity. All that imagery that you're taking to look at for the people in the field to decide where to deploy, all of that also could be used. It's sent and is typically sent a few days later off to Washington, D.C. or Atlanta, Georgia to be processed by FEMA. And those people, and they have people in a dark room look at all the images and pull it together and do damage assessment. And then they send you money, state or federal money based on the damage assessment. But you've got a minimum of 3 to 5 days of getting that information back, which means you can't afford to put certain resources in the field because you don't have guaranteed pay. And none of your fire departments, emergency departments have extra money. So how do we cut that down? How can we cut that 3 to 5 days down? And so, and also improve what's going on with the tactical side. Well, that's where AI comes to the rescue with humans in participatory design. We saw that. And this is a project led by Tom Manzini and Priya Pirali. They were working with Crown Point High. Yesterday, I'll tell you a little bit more. And one of our undergraduates, Riza Karnik. So here's what we're doing. Right, this is actually playing. Okay, and there's no music, so I can talk over it. So you're getting the damage, it said the drone image, and said we're using, here's Hurricane Ian. And then you're going to stitch all of those images together into a big map, right? And then the computer is going to look at where all the buildings are. So all the buildings you're getting there are known to the agency. So that's in purple. It looks there, and then it classifies them as destroyed, major, minor damage, or unclassified, can't tell. So 805 buildings over 400 acres, 4 minutes. on Tom's gamer laptop. Now, building the model for that, to do that required going to Carnegie Mellon's big high performance to train everything. And that's non-trivial to train. But look what that power gives them. Now, getting back to what Dr. Rahman was saying about wildfires here and not having a good database. Machine learning requires good data, the old saying of garbage in, garbage out. So we took 10 disasters over 8 years that we had data from when we flew for responders, for actual missions, and pull that together into the world's largest annotated drone data set for disasters. It's 10 times bigger than the next one. And there's lots of good things, but what's really fun is that we've used high school students to do the annotation. One of the big things when you have a huge data set is getting people to do the labelings. The humans have to do it for the computer to learn from. Takes forever. High school students all over, and now Crown Point has helped us with 247 new data points, and we look forward to that to build in. So that's giving us that high quality data. And we were able to use it at Hurricanes Debbie and Helene. And it was kind of fun. We used it at Hurricane, and so we're giving them, hey, look, here's your dots everywhere. Here's your buildings, and we can give you a spreadsheet with a list of the buildings and the damage, because some of the responders said they didn't even want to look at the map. They just needed the counts to send up to DC or up to the state to get stuff and different statistics and stuff. So we used it at Debbie and Helene with what was fun. And for the state of Pennsylvania, we experimented with a different camera with crewed aviation. But the state of Florida for Debbie and Helene, both are running about 7 minutes to get that data for them. It's taking 2 hours to transfer the files, but once you get it to a computer that can run it, 7 minutes. They loved it. Well, we weren't sure they loved it because we didn't hear anything back. And we said, well, how do you like it? And they said, we want a spreadsheet. Okay, we'll fix a spreadsheet. We'd like you to change the color. And we're like, but how do you like it? It's like, well, when do I train the rest of the people on my team on how to use this? And so we decided that was a yes, that they liked it, right? Because they kept looking at it. It's like, so when do we get more? So with that. So what's happened now is that we've taken that 120 hours, that 3 to 5 days, and we're compressing it. We're just squeezing it down because of AI. We're not replacing people. We're not changing the way the decisions, but we're improving the timeliness of the information going to the decisions to them. And so that's what I love about this part of AI, is that it's not this whole science fiction where we're replacing people with humanoid robots. It's we're just making stuff work. But here was the bonus opportunity. Nobody asked us to do this. I mean, the damage assessment was a clear need, but we were thinking, it's like, well, you know, what's the next thing after this? You see damage, the tactical people are there, and then they have to figure out how to get resources. Sometimes it's in the back of an SUV, sometimes this is tractor trailer truck. Well, what about the road damage? Because you were seeing on some of that bridges are out and stuff. So we said, well, why don't we just also take that data set and do the roads for road damage assessment? And we did it, and there were no standards for it because we went to the Texas Transportation Institute, all these DOT, and they said, well, this is a great idea. We've never thought of it. We don't know how to classify this. So just do it. It will tell you if we like it or not, which is like, okay, whatever. And so we did, and they like it. And so you get this idea of total damage. So think green, orange, you know, red, bad kind of thing. The things like obstructions or the road is totally out are a lot of times covered in sand. That gets, so whether you want to put a 4-wheel drive vehicle there or not, are flooding if there's water, you know. But the bonus thing here is not only did we did that, but one of our students, Stephen Johnson, took classic AI, old school AI, not the ChatGPT stuff, but path planning, how to optimize the paths around it. And so he wrote a program that said, here's your damaged roads. Tell me where you want to go, where your start is. I'll give you 3 roads, one that has no obstructions or no damage, if that exists, one that minimizes the type of yellow, that orange obstructions, and one that has red, that is the absolute shortest, but you'll have to decide if you can get your vehicle over that red stuff, zoom in and look at it. And so that's classic AI, back to the algorithms, the path planning algorithms that you learned in computer science. So what's the future? Where are we going with this? Well, Response is kind of sexy, right? A disaster happens, it makes the news, you see it, and people's lives, their property, their livestock, their livelihoods are damaged. So that's exciting. That's the response and then the recovery. But you know what would really be better is to start thinking about the preparation, mitigation preparedness, getting ready for the next one, preventing the next one, which is again what Dr. Rahman's been talking about. And so that's really exciting. And I think that's an area that has been so totally overlooked and an opportunity here. And so an example, and again, I'm sorry, we're working off of flooding because that's what we do in Texas and Florida, but we do have wildfires in our data sets and things like that. But so here's we're flying. Navajo is a non-navigable river. They've never mapped it. It never changes. You can put the Google Maps overlay and it's so not where it is. Okay, but they have lots of flooding. And they wanted us to go fly over all this remote area, you know, landowners, who knows who owns the land, all of this, figure out what's going on. And we were saying, well, hey, wait, not only are we mapping and getting the terrain and seeing that, but do you know that maybe do you see why there may be flooding, unexpected flooding there? Anybody? Start looking at that bridge. Oh, wait. The bridge is functioning as a dam. I mean, you don't need to do these complex flow models. You just need to start clearing out some of the debris. And look, people are going over and they never noticed because it's mostly as an area when working, you never stop to look. And you got trees in the way. So this is a case of where just preparation, prevention, mitigation, just looking and periodically checking stuff out can save a lot of time and effort later on in flooding. And so I think that's really exciting for us to look at that. So let me wrap up. Let me give you some what I think are some important takeaways. One is that, remember, all of this, we're not replacing people. We're not doing this. We're helping. The way a fire truck helps a firefighter, these are tools for you to use. And more importantly, it's tools that you need to figure out how to use for your needs, for your people, for your applications. And so I really commend Dr. Rahman for that. So this is the time to jump in. This is where you can make the most difference at the beginning. It's like surfing. You want to catch the wave. You're beginning to see that swell. Please jump in and catch the wave here. And this is all multidisciplinary. You saw the errors is a huge thing from industrial engineering and cognitive science. You're seeing engineering and different types of engineering, but it's all together. So many talents are needed to make this work. So don't let the fact that you may not be very good at building stuff and get that hold you back. Please jump in and look at this. And finally, as technologists here at NTU and as citizens, you get to shape this, and I encourage you to do that. And if there is anything my team in particular in the robotics and disaster response, but for the whole societal decision-making process as a whole, we're here. Please let us know. So let us know how we can help you.